Hello everyone, welcome back to Myaba Academy, and today my topic of interest is going to be HEXOSE monophosphate shunt. So what is this shunt and what is this pathway? So the main purpose of this pathway is to make or produce NADPH and two other compounds known as glyceraldehyde 3-phosphate and fructose 6-phosphate. So these are the main products of this pathway. And what are these products for? These products are used to produce chemicals called amino acids and nucleic acids. So basically it's for the synthesis of amino acids and nucleic acids. So this is why we need this pathway. So there are three main products, and this reaction occurs in two phases. The first is the oxidative phase and the other is non-oxidative phase. So to explain oxidative phase, I won't be writing the names of the compounds because it gets hard to retain that information, and I won't be drawing the structures. I would be writing abbreviations to make it brief and easy to absorb. So what happens is the first reactant in this reaction is glucose 6-phosphate. What it does is that it combines with water and produces rubulose 5-phosphate. Here, two molecules of NADPH are produced. Along with a molecule of carbon dioxide, because this has 6 carbons and this has 5 carbons, so that means a molecule of CO2 has been released. What happens next is that this compound ribulose 5-phosphate uses an enzyme called glucose 6-phosphate dehydrogenase to produce 6-phosphoglucanolactone. It's a big word, so I'm writing it in parts so that it's easier to understand. So here another molecule of NAD is produced, NADPH. And then through hydrolysis, phosphogluconate is produced. So we know that in hydrolysis water is used, and lastly, so these are pretty basic reactions. They're straightforward and don't require much like thinking or understanding. That's why I'm not explaining much. So after this, another molecule of NAD is used to produce NADPH, and the final product is rubulose 5-phosphate and a molecule of NADPH. So this is what we gathered from oxidative phase. We started with glucose 6 phosphate, and we ended with ribulose 5 phosphate. This is the first step for the formation of glyceraldehyde 3 phosphate and fructose 6 phosphate. So we'll be needing to produce this, and this will be produced by this in the next phase, which is the non-oxidative phase. So to make things easier, what I did was wrote all of these names in their abbreviated forms, because we are going to make like a tree or a cycle or maybe a chain of reactions. To make those reactions easier to understand, I will be using these abbreviations, so you can look them up in case you are confused. And the enzymes will be numbered. I would not be writing their names, I would be writing their key numbers. So this is how I'll be explaining the enzymes. As we go further down in the reaction, the enzymes will be written as 1, 2, 3, and 4. I would not be writing their names. If I write 1, then that means I'm talking about the enzyme ribulose 5-phosphate 3 epimerase. And if I say SH7P is produced, that means I'm saying sida-heptulose 7-phosphate is produced. So I did this to make it easier for you guys to understand. So this is how the non-oxidative phase begins. So it begins with ribulose 5-phosphate, which produces xylulose 5-phosphate and ribose 5-phosphate. These two in turn produce sida-heptulose 7-phosphate and glyceraldehyde 3-phosphate, and these both produce erythrulose 4-phosphate and fructose 6-phosphate. And now what happens is that this xylulose from the first reaction combines with erythrulose 4-phosphate to produce glyceraldehyde 3-phosphate and fructose 6-phosphate. So the enzymes I talked about are here. So this to produce xylulose 5-phosphate, this uses the first enzyme, which is RFP R5P 3 epimerase, and to produce ribose 5-phosphate, R5P isomerase is used, and to produce these both, trans-ketolase is used, and to produce these both, trans-aldolase is produced, and here once again trans-ketolase is used. So what I did was make this reaction 10 times easier than it usually is. So how many ATPs does this reaction essentially produce? So we got the desired products that we talked about, and in the end we are, so the thing about this monohexyl phosphate shunt is that it doesn't produce ATPs, it just produces NADPH. So since 1 NADPH is equal to 3 ATPs, so 12 would be equal to 36 ATPs. So this is how much energy both oxidative and the non-oxidative phases produce together. So if you have any other queries or any other things you would want to learn about, please let me know, and do not forget to like and subscribe. Thank you.